So, continuing with the balancing of redox reaction by ion electron method, this is the another example. In the previous example, we discussed example which consists of the molecules which we have converted into ions, and again we convert it into molecular form. This reaction involves ions, ionic species. So the steps remain same. The steps are not changing at all. The first step was determine with which species is undergoing oxidation and which species is undergoing reduction, and that is possible only by considering the change in oxidation number. So, the oxidation number of bismuth, let us consider it is A, small a, plus 3 into minus 1, the whole is equal to 0. So, A is equal to 3. So, the oxidation state of bismuth over here is plus 3. Then, if we consider Sn, so let us consider it is B plus 2 into minus 2, the whole is equal to minus 2, it is not equal to 0 because it is not a molecule now. So, B becomes 2. Bismuth free element, the oxidation state becomes 0. Then here, let us consider the oxidation state C plus 3 into minus 2 is equal to minus 2. So, C is equal to 4. Now, if we observe oxidation state of bismuth over here is plus 3, which is changing to 0, reduction. Sn, stannum, plus 2, because it's a stannous now, that changes to plus 4, stannic. So, what is the next step? Identified. So, we will write Bi OH thrice changes to Bi. This is a reduction process. And SnO2 2 minus changes to SnO3 2 minus, oxidation process. So, this is our step 2. The next step is balance the atoms other than oxygen and hydrogen. One bismuth, one bismuth. One NSN, one SN. So, the atoms other than oxygen and hydrogen are balanced. Now, we will go for balancing the number of oxygen atoms. So, Bi OH thrice gives you Pi, 3 oxygen atoms over here. So, I should write here 3 H2O, 3 oxygen atom, 3 H2O, reduction. What about here? SnO2 2 minus changes to SnO3 2 minus. So, here I should write 1 H2O. This is oxidation process. This way, the oxygen is balanced in both these reactions. The next reaction involves balancing the hydrogen atoms, and that is very simple. For balancing the hydrogen atom, we are using H plus ions. So, here in the next step, Bi OH thrice and Bi plus 3H2O. This is a reduction, 3H plus 6H plus. So, I should write 3H plus on left hand side. Then SnO2 2 minus plus H2O gives you SnO3 2 minus 2H plus. So I should write 2H plus on this side, oxidation. So balance the number of atoms, balance the number of oxygen, balance the number of hydrogen. The next step will be balancing the charge. So I'll write BiOH thrice plus 3H plus. So that gives you Bi plus 3H2O. So reduction. Now this side there is no charge, but here there are 3H plus. So I need to write 3 electrons on left hand side. For the next oxidation reaction, SnO2 2 minus plus H2O gives you SnO3 2 minus plus 2H plus. So this side there is a minus 2 charge. Here it is minus 2 plus 2 means 0 charge. So I need to add 2 electrons on this side. So this is my oxidation process. Now till now we balance the charge, we balance the hydrogen, we balance the oxygen, everything has set. Now the next step, we have to cancel the electrons. So we have to equalize it. So for equalization, we have to multiply both the equations with proper integer. 3 electrons, 2 electrons. So this reaction needs to be multiplied by 2, while this reaction needs to be multiplied by 3. So the next step will be 2 BiOH thrice plus 6H plus 6 electrons gives you 2Bi plus 6H2O. This is reduction. This reaction has to be multiplied by 3. So 3 SnO2 2 minus plus 3 H2O gives you 3 SnO3 2 minus plus 6H plus 6 electrons and oxidation. Now if you observe carefully, if we add, electrons get balanced, at the same time hydrogen also balance. A reaction is taking place in a basic medium. So we have to remember this. If the H plus ions are not balanced, then we have to neutralize it by adding OH minus ions. So I will give you the example, I will give the step. If that happens, then what? But first of all, we will complete this reaction. So after addition, what are the things we are getting? So we are getting 2 BiOH thrice plus 3 SnO2 2 minus gives you 2 Bi plus 3 SnO3 2 minus 3H2O, 6H2O, so remaining 3H2O. So what is cancelled? 6H plus 6H plus 6 electrons, 6 electrons. So everything, all this multiplication with the proper integer is to cancel electrons, and that has to be balanced. This is the final balance equation which is taking place in a basic medium. If there is the acidic medium, then also if we can get H plus ion. So we need to understand the reaction is taking place in which medium. Now There is one more method for balancing the redox reaction, that is oxidation number method. All these reactions we can again balance by using oxidation number method, but for practice we will solve few more other examples. Hello. In the previous sessions we were discussing the balancing the redox reactions by using ion electron method. There we have seen two examples, one involved ionic species, the other involved the molecular species. The next method which we are using to balance the redox reaction is oxidation number method. Now in this case, the oxidation number of oxidized and reduced species we are using for balancing the redox reaction. This is one of the simplest method and it also involves a less number of steps as compared to the ion electron method. So we will take this example. Dichromate ion Cr2O7 2- react with iodide ion in presence of acidic medium gives you Cr3 plus IO3 iodide ion. So the step 1 is same in both the cases, that identify which is undergoing oxidation and which is undergoing reduction. That is done by oxidation number. So the oxidation number of one chromium is 6 over here. Here it is -1, here it is +3, and here we have +5. So chromium is undergoing reduction because there is decrease in oxidation number. So here we have reduction. While iodide ion I- changes to +5. So there is an increase in oxidation number. So we have oxidation process. So we have now reduction, we have now oxidation. Now we have to identify or we have to determine what is the net increase in oxidation number and what is the net decrease in oxidation number. For oxidation process, net increase. So before we go for a net increase, for a simplicity, I am taking increase in oxidation number. So increase in oxidation number, final oxidation number +5 minus initial oxidation number, that is -1, 6. So what is the net increase in oxidation number? Since the number of iodide ions are same, so net increase in oxidation number is also same, 6. Now we will go for reduction process. So for reduction process, decrease in oxidation number. So now here we should get a number where the magnitude is important. So what I am taking, I am considering 6 minus 3. 6 minus 3, that is 3. So what is the net decrease in oxidation number? That is 3 into 2, 6. Now if we observe carefully, there is not change in increase in oxidation number or decrease in oxidation number. So here I'll write, here there is no change in net increase and net decrease in oxidation numbers. So, if there will be a change, then what? Let us consider if this is number 3 and this is number 6, then we have to equalize this. How? By multiplying with proper integer. Means suppose if this, instead of this 6 we have a 3, then multiply this by 2. That means those species which are involved in oxidation process will get a coefficient 2. Here no change, so the no coefficient. So coefficient here is 1. So we'll go for the actual reaction now. So what is the reaction? We'll write the reaction. What is the reaction? Cr2O7 2 minus plus I minus gives you Cr3 plus IO3 minus, we have to balance chromium over here. We have to balance chromium over here. Now the next steps are same as that of the ion electron method. But there actually we are dealing with oxidation and reduction process separately. Here we are taking in a one. Means first of all we have to balance the oxygen by adding H2O. How many oxygen? 7 oxygen on this side, 3 oxygens on this side. So we have to add 4 H2O on this side. See here I am writing balance O. I am just saying O, oxygen. Cr2O7 2 minus plus I minus gives you 2Cr3 plus IO3 minus plus 4H2O. Okay. After that, we'll balance the hydrogen. Balance H by adding H plus ions. So, Cr2O7 2 minus plus I minus gives you 2Cr3 plus IO3 minus plus 4H2O. So we have a 8H2O. So I have to write 8H plus on this side. Now interestingly, if all the atoms get balanced over here, automatically charges are also get balanced. 2 plus, 8 plus and this minus 1. So minus 2, minus 1 and plus 8. So that becomes 5 plus on this side. 6 plus minus 1, 5 plus on this side. So charges are balanced on both the side, atoms are balanced on both the side, therefore this reaction get balanced. So this is quite simple way. Once you start practicing it, this step which I have written over here, no need to write, directly we can go for this reaction. So almost 3 to 4 step you can balance whole reaction, whole redox reaction. This is the advantage of this method, oxidation number method. But what is important over here, that you should able to identify this difference. Here we won't get that. So we will see one more example involving oxidation number method in a next session. So here is the another example for the oxidation number method for balancing the chemical reaction, redox reaction. The previous example involved the acidic medium. This reaction involved the alkaline medium. This is a typical disproportion reaction. So let us consider the example. Bromine react with OH minus, that is an alkali, gives you Br minus, bromate and H2O. So we have to identify which is undergoing oxidation and which is undergoing reduction. So here the oxidation state of bromine Br2 is 0, oxygen minus 2, hydrogen plus 1, here Br is minus 1 and here Br is plus 5. So if we observe carefully in this reaction, Br2 itself undergo oxidation as well as reduction. So as we already defined, such kind of a redox reactions are called as disproportion reaction and bromine disproportionates. So here we have 0, minus 1, so decrease in oxidation number, so reduction, and 0 changes to plus 5. So here we have oxidation process. This way we have two reactions, oxidation and reduction, which involve one reacting species, that is Br2. So what we'll do? For oxidation process, increase in oxidation number. So it is 5 minus 0, what is that? 5. For reduction process, decrease in oxidation number is 0, minus of minus 1, so 1. Now if we observe carefully, these values are not same. So I have to convert this value to 5. How can we do that? So I need to multiply this by 5. So here I am writing, therefore, where is the reduction process? The reduction process is Br0 changes to Br minus 1. So multiply this by 5 and hence write the reaction. So what is the reaction we have? We have a reaction Br plus 5Br gives you 5Br minus plus BrO3 minus. I repeat this step, little bit confusing. Increase in oxidation number 5, decrease in oxidation number 1, we have to equalize this number. How can we do that? Just multiply this equation by 5. So what is that equation? Reduction. What is the reduction? Br0 changes to Br minus 1. What about oxidation? Oxidation we can say Br0 changes to Br5 plus. So here we are not supposed to multiply by any integer. Here we have to multiply by integer 5. Hence the ultimate equation becomes BrO3 minus 5Br, 5Br minus. So it becomes what? 6Br. 6Br we can write it as 3Br2 gives you 5Br minus plus BrO3 minus. Now once we balance this, the next step is balance the number of oxygen atoms. How can we do that? By adding H2O. So balance O. So we have 3Br2 plus 3H2O gives you 5Br minus plus BrO3 minus. Next one is balance H. So we have 3Br2 plus 3H2O gives you what? 5Br minus plus BrO3 minus plus 6H plus. Now since the medium is alkaline, OH minus, we need to add OH minus on this side. How many OH minus ions? The number of H plus ions present on other side. So here there are 6 H plus ions, so add 6 OH minus ions on both the sides. So we can say add 6 OH minus on both the sides of above reaction. So we can say that 3Br2 plus 3H2O plus 6OH minus gives you 5Br minus plus BrO3 minus plus 6H plus 6OH minus 6H2O. So what is the final balance equation? Final balance equation is 3Br2 plus 6OH minus gives you 5Br minus plus BrO3 minus plus 3H2O, 6H2O minus 3H2O. This way we can balance this reaction in an alkaline medium also. So in all redox reaction, the important part is this. Now once we balance this reaction, what we can say? 3 moles of bromine reacted with 6 moles of alkalis gives you 5 moles of bromide ions, 1 mole of bromate ion. Now when I am dealing with the moles, it is very easy to calculate. So if one of the species is unknown, we can easily calculate the other species. So that can be useful for mass to mass calculation, mass to volume. Now here all these reactions are taking place in an aqueous medium. So volume of aqueous solution, that also we can calculate. So the later part for stoichiometry comes by use of these balanced redox reactions. Now in some cases there is not requirement of balanced reactions if we use some typical concepts, and those concepts will help us to solve problems without using these balanced reactions. But if we are dealing with the moles, we have to balance the reaction. Where can we use this? In every chapter. It must be in ionic equilibrium, it must be in electrochemistry, it must be in a stoichiometry. In every chapter of chemistry, we have to deal with this. Even in chemical kinetics, in a thermodynamics also, we have to deal with these balanced chemical equations. So that's all for the redox reactions. We'll continue for stoichiometry for some of the problems and some new concepts. Thank you.